Good morning, everyone. We are thrilled to be here at the Flink Forward Asia Summit organized by Alibaba Cloud. In today's session, we are going to talk about how we have powered our real-time streaming data platform using Flink. So let me introduce myself and my team. I am Akash Goel, Head of Data Engineering at GoTo. Along with me, we have Mayank and Raju, who will join me in explaining our journey, the streaming journey, across GoTo ecosystem. But before we talk about more around our Flink journey, let me introduce you a bit about GoTo. GoTo is the largest digital ecosystem in Indonesia. Its mission is to offer technology solutions and improve the lives of millions of people in Indonesia. We have partnered with 20 million merchants, 3 million drivers, and we offer variety of services, wide range of services in mobility, delivery, and fintech through on-demand platform and our fintech platform. Now, our today's session consists of 4 parts. First of all, we are going to talk about why Flink was not enough for us. And then we will see how we solved our challenges around working with Flink alone and how we improvised our Flink ecosystem with some of the enhancements that we did around our streaming platform. So let's try to understand why Flink alone was not enough for us. So Flink is a very powerful tool, but when we try to use it for our use cases, we found that there were a few challenges. Number one, scattered data ecosystem. By this I mean is that we didn't have a unified central streaming platform for our users. Teams had to stitch or use multiple tools in order to achieve or get real-time business insights. So we had to create a unified data platform for them. Second, it was too complex for non-engineers. Setting up a production-grade job was too complex for them. And users just want to write SQL. They don't want to get into the complexity of scaling, deployment, and checkpointing. So what they need is simply, can they write SQLs and get insights? It was leading to misaligned focus because they have clear business goals. And their business goals are more about getting data insights, not about managing the technical complexity. And we have multiple Kafka clusters, and users were getting equipped with what data do they use, how do they use, right? So we had to eliminate that complexity, that they don't have to worry how that data is coming. They should just use that data in the form they want to use. And I will take inspiration from Fang's slide, who just presented a few minutes back. There was a slide which was talking about chaotic data sources and how it was difficult to get real-time business insights. It's really true, because we are facing that problem that data sources are evolving. We have too many data sources, and it is getting complex to get those insights. Now, what is our vision then? So our vision is we should reduce the dependency on data platform teams. We should make our ecosystem, our streaming data platform, more configurable, more self-serve in nature. And that is what we did by building a config-driven, SQL-friendly tool for our users. But that alone was not enough. You still need to reduce time to market. You don't want that building a Flink job is taking more than one day. You have to move fast in this competitive world. So with that, we enabled seamless deployment for our users, which abstracted all the complexity around scaling, checkpointing, and deployments. Third, we had to make it more customizable. Why? Because we are not only catering to non-engineers, we are also creating this tool for some of the power users like product engineers. Now, if you are catering to 2 different types of audience, one who doesn't care about config, they just want to write SQLs. And second, product engineers who are tech savvy and they want more flexibility in providing configs. So we had to make sure like our ecosystem serves all types of audience. And that's where we made it more customizable by providing all types of configs around Flink. And fourth, we had to make sure we take this contribution from the open source community. So the tool that we are going to talk about in the upcoming slides is open source, and we are contributing to the open source ecosystem, and at the same time, many other users are also contributing to it. Now with that, I will invite Raju to talk about more how we implemented it and what is this tool Dagger that helps GoTo evolve in real-time ecosystem. Thank you.
Thank you, Akash. Hello, everyone. Good morning. I'm Raju from GoTo Data Engineering team. Akash just mentioned the challenges and the motivation to build a Dagger tool at GoTo. Now I would like to introduce what is Dagger. Dagger is an open source tool built on top of Apache and Apache Flink SQL or table APIs to solve the real-world, real-time data streaming problems at GoTo. It's a lightweight cloud-agnostic tool, which we are currently running on 3 cloud service providers, including Alibaba Cloud. At a high level, it is a templatized Flink program where all the technical interfaces from the Flink are translated to the features, usable features for our users to solve their problems, equipping with all the necessary capabilities. We can think of it as like, 5 stages where you have the Dagger consumes from the data source, deserializes it, and applies the pre-processors such as like you can add a transformer like deduplicate the records or invalidate the records which are not in the aligned format, and apply the Flink SQL query. Then we have the post processor to enrich the processed output either by using external sources like you can call HTTP services or database, and or you can also transform using internal transformers like SQL within that. And post that, we are going to serialize the data and put it back to the sink, whichever is configured. This is a high-level setup we use for Dagger to function. The Dagger and the orchestrator, which is also open sourced, supports 2 kind of formats. One is Parquet dataset source, and the other one is the Kafka streams. As you can see, there are numerous Kafka streams based on the nature of the data, like throughput or the transactional types. And this was the complexity we wanted to solve at GoTo for our users to not to spend more time on like where to find their data. And we have a stencil which is a protobuf descriptor service which has rich APIs. It helps for all the GoTo products to have a strict data type across the pipeline, and it also solves the data evaluation problems as well. And moving to that, over there you can see we use object storage services. We'll explain more about like why we are using 3 different object storage services over there, which is used for checkpointing, save points, and Kubernetes HA. And then we have the sinks. So once the Dagger processes the output, it either puts it to InfluxDB, it depends on the customer who's using it, for the visualization, or it puts it back to the Kafka stream. We have another tool called Firehose, which reads the data from the DAG stream and puts it to the sink, like for example HTTP, gRPC, or we have mentioned all those things in the slide, including recently we added the max compute and OSS from the Alibaba cloud. Next, I would like to invite my colleague Mayank.
Yeah, thanks, Raju. And hi, I'm Mayank. Good morning, everyone. Thanks for joining. So basically, just to reiterate why we built Dagger. Dagger, we built just to ease the overall streaming in GoTo level. And that was not possible without adopting the schema-first policy across the organization. So basically, schema-first gives the advantage of fixing the contracts. And so to do that, we build a stencil, and that helps us to maintain the schema across the organization. And also, when we, all the teams, whoever producing a data to Kafka, they have to first declare the schema, and also they have to tag topics with the proto so that it's easy for users to discover it and read and deserialize the data. So basically, the Dagger uses stencil CLI in between and try to serialize and deserialize the data for that. And so now that gives us one benefit is we can build the post processors, which allows us to interact with the outside of services like it could be gRPC as HTTP and enrich that events. And along with that, Dagger plus Firehose, which is again the open source tool from our data platform. So we can build a seamless overall ETL jobs in our GoTo organization. So the key capabilities for our Dagger is it should be scalable. So we deploy all our Flink jobs in Kubernetes Operator. We will talk about that in further slides. And so that gives us one benefit is it's scalable horizontally and vertically. In terms of flexibility, so basically one more motivation for building this was to make it flexible for the non-technical folks, right? So they try to write their own code, and they have a custom business use cases which they wanted to extend it. So we don't want to build some system which has the boundaries. We wanted to build a system which can be extendable. And with that, we have allowed users through our DIY portal, the users to write their own Python UDFs and also transformers. And they would be able to do the streaming processing with the Dagger along with this. In terms of extendability, we have separated out the state and the processing. So for the larger window aggregations, we use different state. I mean, basically, we offload that to either HBase or Bigtable or for that matter, any other stuff. And that empower us to basically have to build basically Flink jobs with the more than 60 days of the window aggregations. So some of the DSLs I'll talk about, which is custom to our Dagger. So one of them is Dart. So sometimes what happened is these few we are talking about, we have a lot more for that. But these are the few important ones which is used frequently. So Dart is, you can refer as a Dagger referral table service. We called it Dart. So sometimes what happened is this mostly used by the non-technical folks like the BI or any campaign managers. So sometimes you get the streams of events, but the event doesn't have all the data, right? So for that, you might need certain reference where you can just enrich it. Those are the static data, might refresh in the day or in an hour. So basically, we have developed two things. One is the Dart get and Dart contains. So Dart get, basically, you can prepare a file. You can create a static data in the key value format, put it into any of the OSs. And just in the SQL, if you look at just you can refer dart get, you can give a path which you want to read and what key you want to extract, and then how fast you want to refresh this data. And this will automatically get refreshed when the job is running. And this is useful feature. And then we have a Dart contain which just gets a list of elements, and then it gives you the binary results, either true or false. This is useful for the non-BI, for the campaign managers where they wanted to target a list of, let's say, merchants. And this is very useful for those folks. And then it comes to Longbow. Longbow is one of our very frequently used feature in Dagger. So it's allow us to aggregate the data over larger window in real time. So this is the same thing, like it's just separate out the state and the processing. So let's say consider a case like you want, sometime what you need to do is you have to know the historical data for the given context, right, when the events is coming. And for that, let's consider we have a login event. Now to build the, let's say, a risk prevention system, you need to know how that device or user is using, right? What is their login pattern? So these things is being done using Longbow. So basically, Longbow has two parts. One is the writer and then the reader. So and it works on the you can provide a DSLs in the SQL itself, and Dagger itself will take care of separating this and then enriching with the context itself. So if you look first part, if you look at this is the Dagger reader, you just provide the Longbow write key. You can assign any key from the data, and then we use this Longbow write key along with the timestamp. We just reverse the timestamp to make this latest data come first. And this will get stored into, let's say, Bigtable or HBase. And then it also writes the event to Kafka so that can be one trigger for the Longbow reader. And Longbow reader basically just reads that, and then based on the configure interval, what you want, how fast you want to go for that context. And it gets the data from Bigtable and then assign it, enrich that event. And that will be, then you can use it for the further processing. So also Dagger comes with the observability. Basically, whenever the user, so it's like we wanted to build a system which is like user can deploy the production ready jobs within 5 minutes. So through our DIY portal, whenever users creates the Dagger or Flink jobs, it comes with this pre-built comprehensive metrics. So we track like consumer lag, arcade related metrics like pod, CPU, memory, and then drop events, including a checkpointing states. And and also like we have whatever the things we have extended in Dagger, like post-processor, pre-processor metrics, similar to 4xx, 5xx latency, or DB related databases, interactions related metrics, all is being tracked and will be visible on our DIY portal monitoring tabs. And all these dashboards are already open sourced. And we have, so one of the recent, just to give a context, like we have added a similar, one of the watermarking metrics in our dashboard, like it tells you how far and how past your overall checkpoint watermarking is in progressing. Yeah, with that, I would like to invite Raju for the deployment.
Yeah, at GoTo, we have tons of services generating billions of events, more than 2 TB of data per day being generated. And most of this data are being processed by the Daggers for one or the other use cases from the teams. Earlier, we had around 50 plus Flink Session clusters and close to 1K jobs, Dagger jobs, which are mostly grouped based on the teams. We had a dedicated Flink Session cluster for each teams, and there were common Flink Session clusters where if the team had very few daggers, they could use it. So the challenges we faced with this setup was like managing the Flink cluster was getting difficult for the engineering team. I mean, most of the time we're going there. When a new team needs to be onboarded, we had to set up a new Flink Session Cluster. Or if you want to add a new job, or if you want to scale up an existing job, you had to keep track of all the task slots, which would end up taking more time. There were also like, initially we would ask teams to like how much resource this Dagger would take up. But whatever the initial estimate was there, it was like over the period of time, when the product grows, also the resources starts consuming will be more. And the Dagger ends up getting more resources than it was initially quoted. And another problem, which also is a very common problem, is that if there is any faulty jobs in the cluster, if it ends up, like JM to restart, job manager to restart, then all the jobs were going down. So this was the, one of the main problem which was affecting the uptime of all the Daggers. And at last, the cost attribution. So we are platform team, so we had to attribute the cost for each resources who are using this Dagger. With session cluster, it was actually challenging for us to attribute the cost to them. So what we did is we moved to the Flink Kubernetes Operator. With this, each job is a Flink deployment, which is a Kubernetes custom deployment, right? So with this, we were able to scale up the Dagger both vertically and horizontally, and no more manual management of Flink clusters or the Zookeeper. And any fault jobs would have impact only on that job. So isolation was done, and uptime of all the other Daggers were kept high. And also the cost attribution becomes simpler because Flink deployment is close to Kubernetes deployment as well. So the cost is more on like how many pods are being used. Yeah, and you can see on the right side of the thing, we have 2 ways to deploy our Daggers. One is via console. For the heavy users, they can use our DEX CLI, which is also open sourced. Our orchestrator can figure it out, like based on the configurations where it needs to be deployed. All it needs is like the same binary with the different configurations, like which checkpointing directory which it has to use, or the Kafka source or the Kafka sink, and based on that, we're going to deploy in the particular cloud project. Recently, we are supporting Ali deployment as well. I'd like to invite Mayank.
Yeah, so coming back to the feature engineering part of Dagger, how basically in GoTo, Dagger is utilized for feature engineering. So just to give a glimpse, right? So in like Dagger is utilized for understanding and identifying the data. Daggers comes with influx sync, and also it has it comes with it's Grafana and visualization tools inbuilt. So whenever user try to deploy influx syncs, you have also the visualization ready. So it's very handy for DS folks to just visualize and get the domain context. And also for the data processing, cleaning and pre-processing, Dagger has a lot of transformer, and also it's extendable. users are allowed to write their own transformer and UDFs. So they are able to basically handle the missing data or filter anomaly. We have a lot of UDFs in Diagers which can track the anomalies over window, and then it can flag that out and users will be able to use it as a preprocessor. And also a deduplication can be done using Dagger. For feature construction, we have, you can transform it, you can basically get the temporal features out of any fields. And also you can use geopartial features. We have S2ID, a lot of inbuilt UDFs which can be, which comes handy in terms of the features construction and encoding of that. So some of the, I'll just talk about key use cases which we are, which is being handled through a series of Dagger. So basically just to give you an idea about how we chain the Dagger and other tools which we call it firehouses. So basically we have the enrich Dagger and transform Dagger which just transform and enrich and writes data to Kafka, and then we have a feature Dagger which generates a feature or aggregates it, and then it writes to the in-house feature store. We have developed our own in-house, and also the feast, it can utilize that. And then, or else it can call the actor. So basically, why we directly call the actor in the sense, let's say, Dagger is also utilized for inference as well. Because through post-processor, we have the capability to interact with any of the gRPC or any service which can be either HTTP or gRPC. This is like the SLA prediction. So we have two SLA predictions. One is for the food and one for the ride. So when a user basically book the ride, we use, we try to identify the right actual SLA for how, what would be the time for driver to reach or for the food to be delivered to your home. So in this, we use series of Daggers to predict certain features. I'll not go in detail of that. But yeah, this Dagger is more capable of doing it, and we have hundreds of Dagger running just for these SLAs. Then also dynamic pricing, we basically use Daggers to understand in real time the demand and supply for either for food or for the rides, and then adjust prices based on that. For one of the use cases of fraud detection was the ATO, where the account takeover. We also use their Daggers to actually tag the devices and then try to understand how device is being used against user and what is the user behavior for using a devices, how frequently he's changing a device or how frequently the user is being changed in the device. So these things is being handled through our Daggers and the other ecosystem, and it's like within 5 minutes, users are able to deploy the Daggers and monitor it. Now, one of the use cases, since we are in Singapore, we want to just highlight it, the ERP. So basically, whenever user book a ride here, and the Dagger helps us to basically, try to identify, through Dagger, we try to identify the events from the driver, for the driver location, and try to identify a driver who has the booking. And whenever he passes any of the ERP, we try to basically call the pricing services which can adjust overall at the ERP for that booking. So this is just one of the feature one of the use case we wanted to highlight here. And with that, I would like to conclude our presentation. Thank you.